So what we want to talk about next is what do we imagine this public AI assistant to worldwide knowledges? This is the reason why we are here. And what I want to talk about first is to show you a small pilot that we have created that kind of approximate that. And then we will discuss how we may be able to scale that up to cover like truly all the knowledge in the world. Now that's a big order, and we'll see how. I think that that's the reason why we are here to discuss if that is possible and how do we go about doing this. So to start, let's talk about why we care about having a public AI assistant to knowledge. And if you look at where we are today, with the web, before we do that, we look at the original vision of the web. It is a place where you can share all the knowledge on the web freely to anybody in the world. So that was the original motivation behind this World Wide Web. But of course, today, if you look at the state of the web today, there are just a lot of issues, from misinformation, disinformation, we have clickbaits and ads and so forth. And I don't think I need to spend a lot of time talking about that, but I just want to point out just a couple of things that happened in just last month. We have Meta saying that it will end its fact-checking program on social media posts, and that's affecting over 1 billion people here. And we have also the government taking down web pages, thousands of web pages, and that includes CDC and so forth. And this is really there's a lot of bad news coming here, and we just have to, we really need a lot of people working on bringing the truth out and giving people reliable information. And we need journalists more than ever. But unfortunately, if you look at what is happening with the employment in the newsroom, it has gone down from 2004 to 2019 by a factor of 2, okay? And this is not a good sign. So there are a lot of issues here that we are facing, and the question is, how are we going to get out of it? And as we just discussed, LLMs are taking over the world by storm. Is that going to help us or not? Okay. So the question here is that, first of all, are LLMs actually a threat rather than something that will help us? And that is because LLMs are also full of misinformation, and in the terminology of LLMs, that's known as hallucination. And if you look at this article that was written by the BBC News, they wrote a report. And this is just this year, 2025. And they did a study on Perplexity, Gemini, Copilot, ChatGPT. And they found that 19% of the AI answers, which cited BBC content, included factual errors, incorrect factual statements, numbers, and dates. And then 13% of the quotes sourced from BBC articles were either altered or didn't actually exist in that article. Okay, even if they are citing particular articles, it is still wrong. So there is something really worrisome here. And since Chris brought up the mathematics side of things, I have a mathematician trying out the Perplexity and Google and found that they actually give different answers for on a problem such as finding a limit to this expression here. We got Google getting it right, Perplexity getting it wrong, and if you ask it for a definition, Google get it wrong, and Perplexity getting it right. Okay, so you can't, you have to be careful, because you can't just say, oh, and the weird part is that if you look at what it says from the Perplexity, it shows you the steps. It cited the references, and the references have nothing to do with the step that is cited. And the fact that it provides you with a citation, you just think that it has to be correct. Okay, so this is what is going on. So it is a very serious problem. It's like, what are we going to do with LLMs? And we are saying that, oh, let's use this in our WWK. So is this a threat? There are other issues besides the fact that there is hallucination. We're talking about potentially having a set of oligopolies, because it is really hard to create these LLMs. It's very, there are just a few companies that are doing this? Do they actually have a control over what we are seeing, from the world of LLM? And there's also a question of equity. It is an expensive, LLMs are expensive. Are we able to really reach everybody and not just the privileged people? So what I want to talk about today is LLMs are actually an opportunity. I want to show you that we can actually control the hallucination for particular tasks. And we can actually try to work, we can build an LLM-based research assistant that you can trust. And if we are, successful with this, it can help accelerate even knowledge discovery. And hopefully this will lead us to a public assistant for worldwide knowledge. And this is what I'm going to talk about. So let's talk about the first part. We saw a lot of very, very worrisome information about LLMs. Can we really trust it? Before I do that, I want to show, to answer this question, I turn to this picture here. This is the Bloom's taxonomy. It was created by educators about human education, okay? This is nothing to do with computer science. They said when you teach students, what you're giving them is knowledge from, in this pyramid. At the bottom, they are trying to memorize things. And above that, once you memorize things, you have to teach them how to understand, how to analyze and apply, and then evaluate and eventually create. By create here, I'm not talking about creative writing. I'm talking about research process, how you learn and understand what is out there, and then you create new information based on the information that you have or the experiments that you do. So this is the pyramid of cognition. And what I think of, the way I think of LLMs is that it is really nothing but a speech center, a very good speech center. Because the fact that I can actually speak at this rate and the fact that you can listen to me at this rate is because you have a speech center. You don't really have to go through your big brain to understand what is going on word by word. And to me, LLM is exactly that. It is an amazing memory machine. It memorizes because of the next word prediction training. It learns all kinds of things and it memorizes all kinds of things. And it is bigger, it has a bigger storage than my brain for sure. And therefore, it is amazing in terms of what it knows, or in quote, what it can say, all right? But it actually does not understand. And in a sense, when we ask them to do tasks, it looks like they understand, apply, and so forth. And that is because for us to be able to answer those questions, we have to understand. And we just kind of attribute that to the LLMs and say, oh, they also understand. But there is a huge difference between the true understanding and what we are trying to memorize using this training on next word prediction. And so our research in our group is to focus on the steps above it, okay? So you do have a memory, but the memory can be faulty, but you have to get around that. But it is an amazing natural language processing tool. And if you use it for that, then you can build all kinds of systems, reliable systems even, using this approach. So what we do in our group is that we try to simulate the human cognitive process. We don't just blurt out an answer, but we actually, think through it and figure out how to answer a question properly. We just use LLM as a language processing subroutine. And it is amazingly good at that if you give it simple tasks to do. And we don't use it for knowledge at all. And all the knowledge comes from retrieval. Okay, so this is our approach. So we talked about RAG already, and Chris has already commented on the fact, mentioned the fact that if you take commercial systems, there is a paper by Liu and others at Stanford that shows that even if they are doing RAG, only 60% of the facts are grounded in the retrieval data, which correlates to what we saw with the BBC studies. So that is pretty scary. So what do I mean by retrieval of information? It is not easy to do because you don't just retrieve something and ask LLM to answer. Because if the retrieval information is incomplete or it's irrelevant, the LLM will look at the answer, will look at what you retrieve, and then it will make up the answer that it thinks is better. Okay, so a simple straightforward retrieve and answer will get you actually the wrong answer. And this is why the results are so bad. So how do you solve this problem? So this is how we do it. We say, look, if you ask me a question, I either know it from memory and I tell you what it is, or I look it up. How do I look it up today? I look it up using search, and I also can test, can check, can use the LLM to help me with the answer. And this is what we built a system to do. Our system systematically goes through all these different steps. The first thing it does is that we search information, for example, from Wikipedia, and we get an answer. And well, the answer is as good as Wikipedia. And it could be incorrect, but that's what we are relying on. We retrieve the information from Wikipedia, and then we break it up, we summarize it, we break it up, and then we filter out all the irrelevant information. The filtering part is done by LLMs. And it turns out that something like filtering, they can do it pretty well. Okay, so we filter the information. But you know that the reason why LLMs are so exciting is because you ask a question, it will actually give you related information, not just the specific thing that you ask for. So in the same way, we ask LLM for the answer, but we don't take it as it is. We take each answer, we split them into little claims, one by one, and we fact check each claim. We go to Wikipedia and say, is this correct? If it is not correct, we filter it out. Again, filtering is reliable. That is the most important part. You never ask it to just answer the question. We don't do that. So we take the claims, we combine them, and then we do the refinement, and this is the answer that we would give. So the interesting thing here is that if we actually receive no information from either of the branch, we actually instruct the LLM to say, I don't know. That's the hardest thing to get LLMs to do, is to say, I don't know. And we force it to say, I don't know. And this is how we can get a more reliable result. And you would say, oh, wow, that sounds easy to do. But the devil is in the details. It actually took 3 students, 3 months, and they tried to to make it to be factual, and it took that long to figure out the right prompts to get it to perform at the level that we find acceptable. And so we made it all publicly available. It is open source. You can download it. I don't want you to go and reconstruct the set of work that we have done. So this is why it is so important to have this open source projects. So in conclusion here is that we are using little LLM steps that we can trust, and then we use it to consult with, to get external data. A call like this, a single question like this, we may call the LLM 15, 20 times. Now that is expensive, but that's what it takes. But you can also speed it up. So we try to speed up these cognitive skills. And an analogy of that is like us playing piano. When you learn a new piece, you go very, very slowly. But you keep practicing, and eventually you can go fast. And this is what we are doing with the LLMs. We take the information, we go through all these slow multiple calls to LLM, we get the answer, we generate enough pairs of inputs and outputs, and then we fine-tune the LLM. And this is how we can make it go faster and cheaper. And you can even do it on smaller and local LLMs, and you can get better confidentiality and efficiency. So this is an important step to teach our system how to do cognitive skills. And once you learn the skill, you can compound them and learn higher level skills. So I don't have the time to get into the details. I just show you roughly how we solve one problem. We have a set of papers in the last year on this topic. And I'm just going to give you an overview. There's a lot more information that we can, that we will give you in the tutorial tomorrow. So the first paper published a little bit over a year ago is called WikiChat. We show that we can control the hallucination by grounding in Wikipedia. We check the accuracy of all the generated answers step by hand. Okay, this we show that we actually achieve a 97% factuality. Okay, and And I think that this is really important. It's like if you cannot even answer a question properly, there is no question that you cannot do a research assistant. We spend a lot of time on this. My background is a compiler writer, and our compiler, if it is not 99.9999%, it is absolutely not usable. And this is why we focus on that. 97%, what does that mean? It's natural language. There is ambiguity, and there are, even if you take humans, we do make make mistakes as well. So we're very, very happy that we got the Best Research of the Year award by Wikimedia Foundation last year. So after that, we have a pair of papers on how we get data from databases and knowledge graphs. Okay, we are a big believer in external knowledge. And if you look at the basic idea is how do you translate natural language into formal queries, and that is known as semantic parsing. So there is a lot of work on translating natural language into SQL query. But what we discovered is that in real life, a lot of data are in both free text and databases. You cannot just go to one or the other. The existing approaches typically say, you have a question, I go either this way or that way. But that's not good enough because you have to compound the information to get the answer that you want. To solve this problem, we have created a new query language. It's called SUQL, Structured Unstructured Query Language. Or you can just remember it as Stanford University Query Language. and we have built an optimizing compiler. So you translate natural language into this SUQL query, and then we optimize the retrieval. And we combine information retrieval techniques with SQL techniques, okay, and to get you an efficient answer, and to get you an answer efficiently. And we also worked on knowledge graphs. There is a lot of information that cannot be put into simple tables. And Ed was asking about that. If you look at the Wikidata knowledge graph, it has 15 billion triples. Okay, you cannot possibly encode that in a neural network, even if you have 400 billion nodes. Okay, you have to go external for knowledge graphs. There is just too much information out there. So we have built an assistant that actually are able to to go from natural language to these complex queries on Wikidata. And I will talk more about that in a little bit. Then the next pair of papers is about doing literature search. The question is, can we search so for example, today, if you want to learn a new topic, you would like to see that in Wikipedia because it gives you an overview. But there are many, many topics that are not in Wikipedia. So what this project does, it's called STORM, is that if you give it a topic, it will search the internet and write you a Wikipedia-like article, okay? And it has all the citations and references. We may get something wrong, but every line has citations, and they are pretty good. I mean, I cannot guarantee that everything is perfect, but the whole idea is that I write you the first draft. It is a lot of, it gives you a lot of, it saves you a few days, and it is so much easier to check the references than to go do the search yourself. And then after we created that project, created STORM, we talked to some journalists, and they said, I don't want you to write me an entire paper. I want to control what it says. I want to control what you search. And so we created an interactive version of STORM. We call this CoStorm. And so this allows the user to direct the deep search. And typically, if you think about adding interactivity, you put a Q&A system, just add a Q&A bot. And what we've noticed is that, look, if you don't know this material, you don't even know how to ask the questions. You don't know how to seek the unknown unknowns. And so we didn't just put a QA bot in there. We actually recreated the environment that a lot of students and children learn, and that is to learn from the adults and the experts. So we created a round table of panelists. They can talk among themselves, so you can hear what they are saying. This is how I learn a lot of things as an adult, actually, too. And then you listen to them and you find out things that you don't know. And occasionally you can inject a question or two so that you can direct the conversation to what you are interested in. And that turns out to have much better results than a simple Q&A. So these are some of the work that we have published. And so we're saying, look, we can generate a lot, we can do a lot of curation, we get the information, and we can answer your questions. And the next piece of work I want to talk about is how do you use this information on your job, right? And there are a lot of tasks that people need to do that require a lot of knowledge. So if you take Stanford, if you look at all the students, they all have to figure out what courses they're going to take. You know how much knowledge that they need to do that? They have to figure out what is available. What are the courses? What are their numbers? When are they taught? And they want to know what other people think about the course. They want to know how hard it is to take that course and what is the average grade that you get on the course. All this is in all the databases. So in order to just talk about enrollment, there's a lot of knowledge that you can gather as well. So this is why we care a lot about the knowledge-intensive task assistance. But today, because LLMs hallucinate, most people just say, look, I will just build a simple dialogue tree style agent so that I can control what it says. You don't want this agent to give out a discount when there is none to be had. Okay, so you really have to do the control. So we provide you the control. We actually let you script the conversation. But it is not a script that says, you say this, I say this. That would be totally impossible. What we have created is a declarative script. You say, this is the information that I need. And if you have this information, this is the information that you are going to, this is the task that you are going to provide. So with this definition, we know that our agent will never go off script. Okay? And this is enforced by a runtime system that uses NLP, uses LLM just as subroutine calls to handle the input and output of natural language. So this will completely change how it will change what you can do with LLMs, because now you can insert this and have it talk to your customers and talk to the students and so forth. And we did an experiment and we say, well, how does it compare with function calling on GPT-4 Turbo? They complete a task at a rate of 10%, and we do that at 80%. So I think we have really turned the corner on what we can use LLMs for. So these are all a bunch of papers, and I'm very, very excited to say that we actually now have users. It is, for our group, the first time we have real-life users, because the productization is usually so difficult that we never do that in a research lab. But with LLMs, we can actually make it possible. So I'm going to talk about two sets of applications. The first one is the Wikidata that we talked about. There's tons of information in this knowledge graph, but they are really hard to access. Even a simple question like, who founded Stanford? Well, it's Stanford. But that is the query that you have to give it. You have to give the QID, PID, and so forth. And it's very expensive. It is very difficult. It was so difficult that Wikidata actually has a query forum for people to discuss among themselves, how do you create a query. So here's an example of a real user's query. It is about who plays what musical instruments. And they talk about the people who are affiliated with the Washington School of Music and University of Washington. And you actually want to know how many people play each instrument, okay? It is not just a simple question like, do they have a music school or something, okay? So in order to do this, you really have to search this Wikidata graph. And this is just a tiny subset. You have to know who are the people, you know which instruments that they are playing, and you need to know which schools they are affiliated with and so forth. And you need to navigate this graph. And that is the Sparkle query that you need to write. And this is not the hardest query, by the way. I don't want to show some of the really hardest queries that we have seen. And it will generate you a table like this. And this is all computed from the knowledge graph. You will never get that out of an LLM. So So what we have done here is to say, we know how to do it by hand as an expert. We basically create an agent that does the same thing. But the most important thing that our agent does that is kind of abnormal, unusual, is that it will actually go acquire knowledge to complete the task. It go learn what are those properties, what do they mean in order to complete the task. We give it a set of actions and say, go and work with this work with these functions and iteratively improve your queries so that you can generate the query that for the user. And it is deployed right now at Wikidata Query Forum, and it helps users with complex queries. And at this point, we've logged over 1,700 conversations. We did a sample, and we found that the success rate is about 78%. It is actually better than our test cases because our test cases were very, very difficult. The most important thing I want to note is that what we generate is interpretable. We don't just give you the answer. We say, this is the query that we have executed in SQL and paraphrased in English so that everybody can read that. And you say, this is the answer. LLM may not get the answer, may not understand what question that you are asking. It may get it wrong, but whatever information we give to you is not wrong. And you can tell that even if it answers the different question, that you can detect that and you can modify your query. So the interpretability is very, very important. The second thing I want to talk about is the STORM project. The STORM project was writing these Wikipedia articles, and just give you an example. Oh, we did the experiment, and we worked with Wikipedia editors. And 10 out of the 10 experienced Wikipedia editors agree that what we have done is helpful for their writing. So if you give any example like sustainability, it takes about 3 minutes. It read about 100+ articles. The way STORM works is that we imitate what users do. When we do a search, what do? We look at the results, and then we read some, and then we ask more questions, and then you read some. Okay, so you actually have depth in the way you search. You don't just summarize the first 5 results that come from Google. And you have the depth, and we did it for multiple perspectives, and then we put them together, create an outline, and then we generate the results. So, for example, it would generate maybe a 7-page paper with a description, an excerpt here. This is what I'm showing because I can't show the whole thing. And it generates a table of contents and all the references. Every sentence it says comes with a reference. I may get it wrong, but hey, I'm saving you work. And we really expect you to go check the references to make sure that they are right. But it does save you a lot of time in doing the exploration of information. And we have put it out there. It has been for about half a year. And we have very interesting organic growth, a little bit more than we possibly expected. It was a little bit scary because we don't have that much money. And we have over about 1 million people coming through, writing articles from 224 different countries, 700K articles written, 80,000 conversations made. There are people also reading the articles that we have read. We logged over 2 million of these articles read. And what is interesting is that we got contacted by 5 school districts. They're using it in school. And it is open source. People have downloaded it, and they may be running it and using this, and we don't know, and we don't count that as the users that we have here. And we have about 20,000 GitHub stars. And what I want to point out is that we didn't do any advertising for this project. You may not even have heard about it. And why did we get 500,000 users? And that is because we have YouTubers, TikTokers, and they are making videos of what we are doing to draw people in because they find it useful. Okay, and we cannot afford to have everybody come, and that is one of the reasons why we want to hold this workshop. We really can, we're running out of money. So at this point, I want to turn this over to Cheryl, who has been using Genie for a very, very interesting journalism project.
Thanks, Monica. I appreciate it. So we wanted to try using kind of this work for journalism. One of the things that we do with Big Local News at Stanford is we try to lower the cost of producing accountability journalism. And so you might have known that there was an election this past year. So we worked with Monica's lab to build basically something that allows journalists to use campaign finance data to more easily find stories in that data. Federal campaign finance data is a little bit like a labyrinth. There are a lot of different tables. I mean, it's all structured information, but there's a lot of different tables. There's a lot of problems with the data. It's not super standardized in a lot of ways. And so usually those stories that you see about campaign finance are done by folks, by data journalists who kind of know how to query that data. They might work with other reporters, but they're experts. They know how to dig into the weeds there. And so what we did was we brought in one of those data journalists, Derek Willis, who's done a lot of campaign finance journalism over the years. And he helped us make sure that we could kind of fine tune kind of what we were producing. And so we ended up we created this agent kind of using these data sets from the FEC. We used 10 different tables. We released it in October. And then I used students in one of my classes, Big Local Journalism, and we partnered with 4 local newsrooms to try to tell stories that would be useful for their readers. And we ended up we published 3 out of the 4 stories. One didn't publish because we just couldn't get our fact checking done in time. But aside from that, the results were pretty good. And what do? Is we literally just ask questions of this agent from the campaign finance data. But the real benefit to the agent, kind of like what Monica talked about with citations, is that the way the agent works is you can actually here's just some examples of the stories. You can actually fact check as you go with doing this analysis. So these are just, I want to kind of quickly tick through the stories that we produced and then talk a little bit more about that fact checking. So one was published here in the Bay Area with Local News Matters, Bay City News, and it was really taking a look at Ro Khanna and how much money he was bringing in and how he might use that money for his future political career. And we took a look at the kind of top fundraising by the 5 California House candidates. A very local story, again, one that most local newsrooms wouldn't have the wherewithal to really necessarily dig into. The other story was for the Honolulu Civil Beat, where we again took a look at kind of the congressional folks in Hawaii and how they were using their money and in what ways. And kind of a little bit more about Takuta and how she was outraising a lot of her other candidates, even though there was no worry about any kind of races in Hawaii, that they have this incredible fundraising apparatus, and in large part because they have a lot of defense industry there. And so it kind of dug into that. We did a story with the Atlanta Journal-Constitution looking at abortion and ads on reproductive health and how those increased. And so we really ended up marrying 2 databases with this. We used the campaign finance data to show us where the spending was happening by region in Georgia. And then we were able to get another data set that took a look at kind of just ad buys and how those kind of dovetailed. So that was a really interesting story. And I think, nobody had really examined it at that level before. So in that case, this is just the kind of the tagline at the bottom of the story. You can see that they say that, we worked with Data Talk with Stanford, this tool that translates natural language into queries of databases. So the AJC, like a lot of newsrooms, has an AI policy. And so they wanted to make sure that they understood how we were using this tool and that they could reference it and in a way that wouldn't, that they could be confident that the numbers and the data were accurate. This story is not one that came out of my class. So I think this shows the promise of what is possible with these tools. So the main monitor Big Local News had a relationship with, they just reached out and said, hey, we really want to take a look at spending inside the state and spending outside of the state. in terms of contributions. And so we were like, oh, well, you can use this tool, Data Talk. So they did, and then they worked with us to just make sure, again, that the queries were accurate, and they published their own story. So what are the key components to Data Talk? The key components are you can do real-time fact-checking. There's transparency into the queries, and the queries are shareable. You can actually go into a dashboard, save your query, make it public, share it with somebody else. So if your editor wants to see exactly what happened and make sure that it went to the right, like you were pulling information from the correct tables, or have somebody check it, you can do that. There's a saying in journalism that I unfortunately taught my children that it says, if your mother says she loves you, check it out. And that's what journalists do. They want to check out everything, right? And so this tool makes it possible, because what it does is it generates the query, and it tells you, like, oh, here's I say my question, and it translates that question into a SQL query. It shows you the query. It explains the query in English in case you don't know SQL. And then it says, oh, here you can open it up, you can change the query, you can save it, you can share it. And that levels up the confidence of the journalist using the tool, because they know that they can really verify that the information is there, nothing was hallucinated, it is accurate. But to Monica's point, this saves time. This lowers the cost of doing accountability journalism. If I'm a regular journalist who doesn't specialize in data journalism, I now have access to being able to do that kind of data journalism. I might need to learn how to read the code a little bit, but that's a lot better than knowing from the scratch how to write that code. Or maybe I can at least go show it to a data journalist on my team and say, is this correct? Is this right? This is what it pulled. And that makes life a lot easier, a lot faster. And for those really strapped local newsrooms, it makes it doable. So that's kind of why I think this was a success. And it wasn't just me who thought this was a success. Florent Dorenz from Hugging Face posted on LinkedIn after he tested it out. And we saw a lot of interest from other journalists, again, like the Main Monitor, in checking out what they could do by asking questions of these data sets with just words, right? And it wouldn't be possible if we didn't have kind of all of these components, I think, put together. So what are our next steps with the Data Talk model? We'd like to move beyond just FEC campaign. I mean, that's a great pilot. We want to continue that. But we have another platform called Agenda Watch, which if you're interested in, Serdar Tumgoran, my co-director at Big Local News, is in the room. It scrapes local government agendas in minutes at scale across the local governments across the US. And we think we can use this same kind of agentic approach to being able to query information from the local government level to see what patterns are happening. We could use this same kind of approach with newsroom archives. There's a lot of valuable information in there that it would make it much easier for us to access. State campaign finance records. We did FEC. There's a lot of state campaign finance records and a whole lot of other things. So we think there's a lot of potential here, and that's kind of just wanted to go over that. And if you want to talk more about how we might use this or how we might work together, we'd be excited to do that. So I'm going to now hand it over to Trevor Getz, right?
Thanks, Cheryl, and thanks, Monica, and everyone here. If you were looking for a bunch of AI skeptics, you'd be hard-pressed to find a better group than historians. We are mighty suspicious. We're suspicious because we think our students will write their papers using generative AI. We're suspicious because we think it might replace us in our jobs. And a good friend of mine, who I know is watching this conference on his computer right now, suggested to me that I think in terms of what tasks do I have that I would want to be replaced at, that I would actually want something else to do, that I would want generative AI to do for me. And one of those tasks is that I read through a lot of microfilm. I work with historical newspapers, and just about every historian I know, and there are a number in the audience today, has some kind of archive of data and information that is very difficult to work with. And so generative AI presents an opportunity to work with these corpora, some of them small, some of them large. But then again, the additional obstacle is that we have this ethical responsibility with these archives these corpora that we work with, to make sure that that information isn't alienated to them. And as we'll hear, I think, in a panel that's going to happen in a little while, there are suspicions among many of the communities that we work with. So I want to welcome you to History Genie, which I think brings together these three problems and provides a solution. And probably I'm several times by mistake going to say we did this and we did that. I did very little in terms of the digital side of things. Sina, who's sitting over there, and others in Monica's lab did most of the work. But I am really proud of this work, and I'm going to show you what my students and colleagues have been doing with this corpora already. So the corpora that I'm talking about, it started with the African Times, which is an almost entirely unknown newspaper produced through correspondence between people of African descent in the 19th century, most of them located in Africa. And now it has grown to include the South African Commercial Advertiser, which Grant Parker asked us to look at, and I think it's going to grow to a lot more newspapers soon. And what History Genie does is it allows us to do a lot of things. Well, first of all, I should say, without generative AI, it wouldn't have been able to do the OCR, if you will, to pull in these microfilms and these PDFs into readable text, which of course humans checked and helped to make sure that it was correct. But we have this beautiful ability then to browse all of these newspapers that hadn't been accessible before with high levels of accuracy. We can search using a search that also uses generative AI. One of the searches I did was for eugenics, for example, a word that didn't exist for most of the time that this newspaper existed. And it pulled up stuff about disability and gender and race and things like that that were related to AI. You can also use a sentence as a search, which I thought was really useful as well. And then, of course, you can chat with it. And every time you do, it pulls up citations. And so you can go and you can check that information yourself. And if you're a historian, of course, or a history student, that's what you want to do. It can also write reports. And I will say that I'm able to compare the reports that it writes based on this specific corpus of materials to what my undergraduate students are producing. And it compares favorably, I will say. And then Monica's lab helped me and my colleagues who are working in this, including Robin Chapdelaine from the Center for African Studies here, to go through and to assess how useful this was, to help develop ideas and tools so that it can think about things like significance and change over time. And then we did some interesting experiments comparing it to printed texts that are out there covering the same time and place, in this case, the UNESCO General History of Africa. But I want to focus on the fact that I had a class of 35 undergraduate students at San Francisco State do research reports on a period of time in a place that I know well, using a corpus that I know better than probably anybody out there. And I studied their output, and I also studied their experience. And I will say that they found problems. They were able to report issues that we could then work on. When I did a full evaluation of how students used this corpora and used the different features, I found that they were able to use all of the features in the development of their research papers. And then I looked at their research papers and found that their research papers were actually enormously successful. Now, you may note that 20% plus 35% plus 25% doesn't add up to 100. Not every student succeeded in producing a good paper. Anybody here, I bet many of you have taught, and you know that that is a normal thing in a college classroom. But nevertheless, what they brought out included a startling number of papers looking at incidents, themes, experiences in African history that had never been discussed before, that did not appear in the literature, that still don't appear in the literature, which is pretty startlingly high, actually, 20% original research in that really they were looking at something that hadn't been discussed before. A much larger percent, about 35%, touched on and could relate to literature that was out there, but could add these new pieces of data. And 20%, a very interesting 20%, actually introduced African perspectives from these African writers on events that weren't happening in Africa and that we didn't know that Africans commented on. Things like Zionism in the 19th century, things like temperance movements and the abolition of alcohol. Both my students and the colleagues that I'm working with now seem to be obsessed with alcohol. That's actually okay. When I worked on anti-slavery in 19th century West Africa, and I was looking through the British archives, anti-slavery had far fewer comments than "our ice machine is broken and send more gin," which British officials often wrote back to London. That's not a quip, that's actually true. I never published that paper, but I should get back to it. But nevertheless, so I now have colleagues working on this material. One colleague who recently finished a PhD at Tulane University, who changed an entire chapter based on searching and using the chat to understand different sources on a particular city throughout this corpus. Two others, one of whom is working very interestingly on trade routes and where they existed and how they moved, which requires a great deal of sort of digital analysis as well. So I'm committed to building a community around these newspapers and digitizing some additional newspapers that also are completely unavailable outside microfilm in most cases, the British Newspaper Library. But equally importantly, and there are some here today, as soon as I started to talk about this material, many other historians approached and said, I'd really like to see if this is useful for me as well. It's eminently scalable. From what Sina tells me, the second newspaper that we did was much easier to pull in and to build a framework around than the first one, and hopefully it becomes even easier over time. And the amazing thing about that, of course, is if we can make it possible for scholars, communities of scholars, or scholars in conversation with the communities that are the subjects of their work, to kind of use this as a kind of out-of-the-box way to develop and integrate their own material into this worldwide knowledge assistant. So I'm ecstatic at this moment at how well this has worked for us, and I guess I'm a historian, so I'm not often ecstatic about anything. That's it. Thank you very much, and thank you, Monica, for the opportunity.
Well, I want to thank Trevor and Cheryl for working with us. We learn a lot in this in these experiments. And so, for example, we thought that we can just point GPT-4 at text reconstruction as here is a newspaper and gets the text. That is not true. We have done a lot of work on this, and we have combined AI techniques with traveling salesman algorithms and stuff like that in order to come up with what I believe is currently the best reconstruction tool there is, and we are very, very happy to share. Thanks to Sina, of course, who has been doing so much of the work on this topic. Another thing that we have learned is that we need to capture expert knowledge. It is not just a database. Okay, there's a lot of expert knowledge. And what we want to do is to generalize our system so that anybody can any expert can add in their knowledge without calling a CS programmer, okay, to work this knowledge or hard code this knowledge into the system. And so these are really interesting research topics going forward. So Genie is, the reason why we are able to do this project is because Genie is built to be domain adaptive. We didn't have to do a whole lot of work for every single databases, every corpus out there. And these are some of the things that we have done. And the focus here is to make it available as a general tool for your data corpus. You can have digitized material, free text, SQL, or knowledge graph schema, and you get chat, search, browse, and research. That's the STORM project we talked about. And it is also LLM and search engine agnostic. And it is an open source software. You can download it, you can modify it for for whatever you need to do. And because it is open source, we have lots of people helping us with this code base. And we have now put in, with the help of our partners here, is an interface, for example, to Light LLM. It actually connects to 50 different models. All the major LLMs are up there, so you can experiment with all of them. And we also have a choice of search. And you can also point to a private repository. So for example, we have indexed Semantic Scholar. So now we can apply what we are talking about to Semantic Scholar. And we can also help host your data. And we have a tool our students use this for our class projects. And you can upload your data, and you will get this new interface without you like downloading the source code and so forth. So there's a lot of material that we have done, and if you are interested, please go to the tutorial, and we will show demos of how these systems work. And these are the people that you are going to be listening to, and they are the PhD students who have done tons of work on and you can hear it from the horse's mouth. So that's where we are today, but I want to point out that this is just the beginning. There is a long research road ahead. We are more or less at, we're doing research. When we say research, we're doing literature search. It is not real research yet, and that's what we need to do. We want to be able to curate across hybrid corpora. We want to talk about insights, test out hypotheses. This is all to accelerate the process. I am actually, the reason why I realized that we need a research assistant is that we were talking to my colleagues in the sustainability school. And they said, I need you guys to help us. And I said, I don't know anything about sustainability. But they said, I don't have enough money. I don't have students. I don't have time to process all this information out there on sustainability. And we really need AI to help you. And that's one of the motivation for us going really into research assistants, automating that process, providing you with the first round, and then the experts can go work on the data. So today, the one thing we are working on is how we can, instead of generating just text, collecting from information from the internet, we also now can put tables in that are answers that we draw from databases. So now you can actually make new viewpoints instead of just reporting what other people have done. So this is work in progress. We want to be able to do causal inference. We will actually want to ground it in more, in theorem provers and so forth, so we know what we are doing. And all this is leading to the point where we want to have a new round of post-training of LLMs that is based on cognition, that is to improve the cognitive skills rather than just memorization. We kept talking about how LLMs hallucinate. And as a matter of fact, we also discovered that LLM can get to a point where it can find inconsistencies in human curation. And we are estimating that you can find, it's a combination, it's not just pure automatic. With humans, with help from, with experts, we estimate that there is about 1 inconsistency in every 10 paragraphs today in Wikipedia. So we are beginning to learn more, and we can do more with the knowledge. Another thing I want to point out is the fact that we really need research tools for education. We were surprised when the school districts come to us, and we asked them, why are you doing this? They said, first of all, the students need to learn how to use AI tools. We need to hone their research skills. We have to also prepare them for a career in the future that is shaped by LLM. And research activity is one of the activities that humans will be engaging in. So I think that this is also another important aspect. For third, I want to talk about the fact that with LLMs, we can truly break down the language barrier to knowledge. The wiki chat that we have created has access to 25 Wikipedias. It integrates information from these different Wikipedia, and nobody knows what is like the full scale of knowledge across all these languages. One of the most important things as a side effect of this is that it means that the non-English speakers can learn from the English Wikipedia, which is really the largest Wikipedia that is. Another area, we kept talking about news and misinformation. What we really want to do is to break down the silos between countries. So we want to hear what other countries are saying to their citizens in their languages. So right now we have this is a work in progress, and we have, for example, used Common Crawl. We have a database of about 53 international publishers. If you give me a topic, we actually, first of all, take the information and get it from the country that you're interested in. So for example, this is from Iran, this is in Farsi, and we provide a translation. The second thing here is that, the important thing that we realized is that it is really hard to even read other people's newspapers because you don't have the background. So we also use Storm to generate a background so that you can interpret the article that we are showing here. And next is that we also do the comparison and contrast between newspapers from different countries. So here is an example of some similarities and some of the differences, because I think that understanding how the news is being reported across the world differently is really critical to our concept of having worldwide knowledge. So in summary here, there are these 3 main points that I think we can look forward to in the future, where we truly accelerate knowledge discovery, help in education, and improve the access to knowledge all around the world. And I think that this is kind of like the mission of the universities. But the question is, how do we scale? We have a very small group. We try to make our system all, adaptive, but you still need work for each of the databases and so forth. So what I want to talk about is that we really need to pull our AI research effort together. A lot of people are looking at, what we need to do using AI for their data. Why can we work? We want to say, let's work together. We want to support and accelerate adoption, and we want to be able to get to real users so that we can get the feedback so that we can fuel for future research. So what we have discovered as I was preparing for the workshop, that there is a really large ecosystem of open data providers. Besides Wikipedia, Wikidata, we have Internet Archive, Common Crawl, Data Commons at Google, and so forth. These are really invaluable data sources, and they have been used for training. Okay, and the question really is, does it mean that LLMs trained on these sources will become an intermediary between users and data providers? The scary part is that it is not a very good intermediary, okay, because it is approximating. It actually doesn't know all the true long-tail details that is in all this data corpus. So there is a report in 2010 on this topic of sustainability, digital preservation, and access. And I think that these are just brilliant conclusions here. The first is to say there is no access without preservation. That's obvious. But there is also no preservation without access, and that is from the economic perspective. You can preserve it and nobody accessing, nobody will be supporting that effort. So the question really is, in the world of LLM, what do we need to do to keep all our data providers alive, okay? Because the existing corpora are just too hard to access. So now they are being eaten up by LLM and spit it back out approximately to end users. And that is not a good place to be. And so what we're saying here is that if we have an open source research assistant, it will greatly improve the access. The providers can own their own users. And so at this point, after talking to all these people, we are actually exploring collaboration across Internet Archive, Common Crawl, and Data Commons. We have already been doing a lot of work on Wikipedia. So one of the questions is the cost. So I want to show you what it means to support the 500,000 users that we have. If you look at Storm, the cost breakdown is that it takes us actually 75 cents to produce an article. It turns out that 75% of it is on Bing search. It's only the 25% is on LLM. And that is because we are using GPT-4o mini. And as a matter of fact, we show you all the different sources of LLMs and search engine. You can bring it down to even 5 cents. But, the quality may be an issue at that point. But you know that the price of LLMs are going to be dropping. So what is important is to save human efforts. Instead of something that you spend, take days, we can finish it in minutes. It accelerates the discovery of knowledge. It reduces the barrier to entry, which is really important. And what I think is that if you look at that ratio, the AI interface is a marginal expense to increase the return on preservation. Okay, you preserve, you have to improve access. And I think that AI is a really good solution. So this is the idea of the WWK, www.knowledge.org. This is a website that we put up. It's a pilot. We see this as a free multilingual AI research assistant to open data. And we want to do this in partnerships with providers. We are not just an intermediary. We share our costs, we share our effort, and share our funding. That's that's the basic idea, because this is going to be a nonprofit or website. And we have open source AI technology. That means that you don't need to start from scratch or start from wherever. You can use what we have, and we can work together and to create the best AI technology there is. We can help host if this is desirable. And we would like to see this as a way of bringing the research community together. We can build up the community, and we provide the support and consultation. This is something that we just could not possibly do today in our little research group. So I just want to leave you with this slide here, and that is that there are a lot of major efforts in the past, from the beginning of the public libraries, something like the open source Linux, from the World Wide Web and all the various different open data providers. There are a lot of people involved, and there are lots of different kind of funding from individuals, the government, DARPA, NSF, and also large companies, Microsoft, Google, and so forth, as well as the consumers themselves. They contribute by time, with their money and with their time. So I think that this is what I think this is really a good time to look at open AI, and I look forward to our conversation today. And lastly, so this is the conclusion. It's like I just want to remind everybody about the preservation and access and the potential impact that this system can have. And I just want to close with my thank you to our sponsors.